Okay, we've all been there, right? You see this giant, nonsensical block of text that's supposed to be an image or a file. And it looks like a secret code or maybe some super complex math equation. But what is it really? Today we're going to crack the case on Base64 and figure out once and for all if it's a clever mathematical system or just a fundamental piece of coding.
You have absolutely seen this before. On the left, you've got a simple, pretty image of a butterfly, and on the right, a giant wall of text that claims to be that exact same butterfly. Now, this isn't some weird glitch in the matrix. It's literally the image's data, just wearing a disguise. The real question is, why on earth does it need one?
So yeah, what is this stuff? Is it meant to be secret, like some kind of encryption? Or is it the output of some crazy math problem? Let's start digging and follow the clues, starting with the most obvious one we've got.
And our first clue? Well, it's been hiding in plain sight this whole time. The name itself. Base64. That base part immediately makes you think of math, doesn't it? The number 64 is the real key here. I mean, in math and computer science, we're always hearing about number systems like base 2, binary, or the base 10 we use every single day. So it's pretty natural to just assume that base 64 is another number system, just one with 64 different digits. Makes sense.
And here they are, the 64 digits, although it's really more of an alphabet if you think about it. It's made up of 26 uppercase letters, 26 lowercase letters, the 10 numbers we all know, and then 2 special characters, a plus and a slash. You add all those up, and what do you get? Exactly 64 unique symbols. So far, the math theory seems to be holding up pretty well, but this is where the plot thickens.
Because here's the big twist. Despite the name, Base64 is not a number system. Not at all. Its real mission, its whole purpose for existing, is to be an encoding system. And trust me, that is a world of difference.
So what is an encoding scheme? Well, its job is simply to convert information from one form into another. That's it. Think of it like a translator. It's not there to do math with the data. It's just there to change its appearance so it can travel around the internet more easily.
And this distinction is absolutely crucial. A number system like base 10 or binary is for, doing math. An encoding system like Base64 is for representing any kind of data. We're talking images, audio, whatever you can think of in a totally different format.
And here's why that's so incredibly important. A computer stores an image as binary data, just a sea of ones and zeros. But a lot of systems we use every day, like HTML or email, they're built for text. And if you try to shove raw binary data in there, it can cause all sorts of errors. Base64 is the bridge. It converts that computer-friendly binary into a text-friendly format that can travel safely through all those systems.
Okay, so now we know why it exists. But how does it actually pull this off? Well, it all comes down to a really clever bit of math and a simple little swap.
This right here, this is the mathematical heart of the entire system. Think about binary for a second. How many unique combinations can you possibly make with 6 bits? Well, the answer is 2 to the power of 6, which equals, you guessed it, 64. And that is not a coincidence. With exactly 64 symbols in that Base64 alphabet, each symbol can perfectly represent one unique 6-bit chunk of data. It's a perfect match.
Let's walk through the classic example everyone uses, encoding the word man. So a computer sees the 3 letters M, A, and N as 3 separate 8-bit bytes. That gives us a total of 24 bits. Now here's Base64's clever trick. It takes that same 24-bit stream and just regroups it into 4 6-bit chunks. Then each of those 6-bit chunks maps perfectly to one of our 64 symbols. And just like that, man becomes TWFU. 3 bytes go in, 4 characters come out. Pretty neat, huh?
Now, this isn't just some cool party trick. It's an incredibly useful tool that you see all over the web. So let's take a look at why it actually matters, both for programmers and for you just browsing the internet.
Okay, one of the most common uses is sticking small images directly into a web page's code. So instead of telling the browser, hey, go fetch this separate image file, a developer can just convert the image into Base64 text and paste it right into the HTML. This can sometimes make a web page load just a little bit faster because it doesn't need to make an extra request out to the server.
So here's the bottom line. Programmers use Base64 to solve a really fundamental problem. They need to move binary data through systems that were only ever designed for text. Base64 makes that data portable and safe, and it makes sure that no information gets scrambled or corrupted along the way, whether it's inside an HTML file, a JSON data structure, or even an email attachment.
So, to finally answer our original question, let's just put everything in context. You've got base 2, binary, which is a true number system for machines. Then you have base 16, or hexadecimal, which is basically a number system humans use as a convenient shorthand for looking at binary. But base 64? It's in a totally different category. It is an encoding system designed for one primary job: safe data transport.
So is base 64 math or is it coding? Well, the answer is, it's both. It uses a simple, elegant mathematical principle that 6 bits can represent 64 symbols to solve a fundamental coding problem. It doesn't change what the data is, it just changes its outfit. It's the exact same data, just in a new form, which gives it a much wider usefulness. And really, what could be a more elegant solution than that?